Hello everyone, welcome to your physics class of class 8th. I hope you all will be fine. Students, today in this video we will study about household electricity. Okay, so let's begin our class. Household electricity. In our daily life we use electricity in different ways such as to light our home, school, office, etc., to run fan, television, heater, radio, and all other electrical appliances. Now, what is the source of electricity? So, the different sources of electricity are cells or battery, mains, electric generator or dynamo, solar cells. Okay, now the cells or battery provides us current which remains constant with time, means that remains constant with time, that does not change. This current is called direct current or DC. The mains and electric generator provide us alternating current which changes its magnitude and polarity with time. Okay, so that is known as alternating current or AC. Now, electrical energy and power consumed in a circuit. A cell has a potential difference between its electrodes, that is, anode and cathode. The potential difference is defined as the work done in moving a unit charge from one electrode to another, and it is expressed in the unit volt. Okay, that is symbol V. So what is potential difference? Potential difference is defined as the work done in moving a unit charge from one electrode to another electrode. Now current is defined as the rate of flow of charge in a unit time. Means current is defined as charge per unit time. Okay. It is measured in ampere. Unit of current is ampere. Okay. Now suppose a current I flows through a conductor of resistance R for time t, where a source of potential difference V is connected across its ends. Okay, now we need to find the amount of electric energy supplied by the source. So for this, we know that potential difference is a work done in moving a unit charge. So work is W is equals to QV. Okay, charge multiplies by potential difference V. But we know that current I is equals to Q upon T. Now using from here Q value of Q is equals to IT, and by putting this value of Q in this relation, W is equals to VIT. This gives the electrical energy W supplied by the source in providing the current I for time T in the conductor under a potential difference V volt. Okay, so this is a electrical energy in terms of potential difference, current and time. Now power is the rate of doing work. Rate of doing work is known as power. Power is equals to W upon T. And by keeping this value W is equals to VIT in this relation, from here we get P is equals to VI. Okay, that is potential difference multiplied by current. Okay, now unit of power is watt. 1 watt is equals to 1 volt ampere. Now supply of power to a house. To supply electric power to a house from the city substation, either the overhead wires or cables on poles or an underground cable is used. As you all have seen, the cable has three wires: live wire, okay, neutral wire, and earth wire. The neutral wire and the earth wire are connected together at the local substation, so that the neutral and the earth wire are at the same potential. Okay, as these two wires, neutral wire and the earth wires, are connected together at the local substation, so these neutral and the earth wires are at same potential, that is 0 volt. The live wire, also called the phase wire, is at 220 volt and it carries the current from the source to the distribution board, while neutral wire is for the return path of the current. Okay, and the current passes to the earth through the earth wire. Okay, now color coding of live, neutral and earth wire. Live wire is red or brown in color. Neutral wire is black or light blue, and earth wire is green or yellow. Okay, so these are the color, voltage and purpose of all these three wires: live wire, neutral wire and earth wire. You have to read this. Okay, now Connection from pole to the distribution board. First, a fuse of high rating is connected to a live wire at the pole or just before the meter. This fuse is known as company fuse, and the rating of this fuse depends upon the connection that is taken from the company. Now, after the company fuse, the cable is connected to an electric meter, and this electric meter is usually fitted wall of the house, outside wall of the house. And from the meter, connections are made to the distribution board through the main fuse, okay, and a main switch. The main fuse is connected to the live wire, while the main switch is connected to the live wire and the neutral wires. Now, commercial unit of electrical energy. Electrical energy is generally measured in a unit called BOT, Board of Trade unit, or kilowatt hour. And 1 kilowatt hour is defined as the amount of energy consumed when an electrical circuit appliance of 1 kilowatt is used for 1 hour. So how we define 1 kilowatt hour? 1 kilowatt hour is defined as the energy consumed by an appliance of power 1 kilowatt in 1 hour. Okay. Now energy consumed in our houses, shops, factories is measured in kilowatt hour. Power is equals to energy upon time. Okay, and from here we can calculate energy as power multiplied by time. So 1 kilowatt hour is equals to 1 kilowatt into 1 hour. That is 1 kilowatt hour is equals to 3.6 into 10 raised to the power 6 joule. This is a relationship between kilowatt hour and joule. Now electric meter. Electric meter is also called the kilowatt hour meter because it measures the amount of electrical energy consumed in unit kilowatt hour for which the electricity bill is to be paid by. Now, electric fuse. Electric fuse is a safety device that is used to limit the current in an electric circuit. It helps us to prevent our electrical appliances from damage if excess amount of current flows in the circuit. It consists of a fuse wire uh, which is stretched between two metal terminals T1 and T2 in a porcelain holder. The holder fits into the porcelain circuit. As you can see here, socket. This is a fuse that is used in the circuit. Okay. The fuse wire is a short and thin piece of wire of a material of low melting point. Generally, a fuse wire is made up of alloy of lead and tin, 50% of each metal. So, fuse wire is made up of an alloy of lead and tin. Now, purpose of fuse is to prevent damage if excess amount of current flows in a circuit. When there is a short circuit, the fuse wire gets heated up to an extent that it melts. As a result, a gap is produced in the live wire and the current becomes incomplete or breaks. So no current then flows and the appliance or the circuit is saved. Okay, and after removing the fault in the circuit or the appliance, a fuse wire is fixed between the terminals T1 and T2 in the holder to complete the circuit again. So if excess amount of current flows in the circuit, then the fuse wire melts down and breaks the circuit. And this is how the electric any appliances can be saved from damage. Now, characteristic of a fuse. It is a short wire with a low melting point. The fuse wire is made up of alloy of lead and tin, and it melts at about 200 degrees Celsius. Fuse wire is connected in series with a live wire. Its temperature rises much faster than the connecting copper wires as an excessive current flows because its resistance is higher than that of the connecting copper wires. Now the third point is the thickness of the fuse wire depends on the current rating of it. Higher the rating, thicker is the wire. Okay. Now these days miniature circuit breakers MCBs are used. They switch off the circuit in a very short time, nearly to 25 milliseconds in case of short circuiting. Now nowadays MCBs are used, that is miniature circuit breaker are used. It is an automatic switch that is nowadays used to protect the household wiring from the excessive flow of current in the circuit. All of you must have seen at your homes, when the current flows in excess, the MCB automatically falls down to break the electric circuit, and after some time it reset. Okay, now household electrical circuits. In your house, you notice that each electrical appliance is used separately. You can light a bulb without running the fan. You can light the bulb in a room without lighting the bulbs in the other rooms, so and so on. And if one appliance gets affected, gets damaged, it does not affect the working of the other appliance in the house. All the appliances work at the same voltage equal to the voltage of mains. Now, how this happens? Now the question arises, how are these appliances connected in the circuit? Okay, to understand this, let's see this example, this experiment. Take two torch bulbs, as you can see here, mark them as A and B. Now connect two bulbs to a cell through a switch as shown in this figure. These bulbs are connected to this cell and this is a switch. Now switch off and take out the connections of the bulb B as shown in the figure. Here you can see in this figure, here the switch is, now switch off and take out the connection of the bulb B. Again close the switch. Now again close the switch. You will see that the bulb A does not glow. Why does this bulb A not glow? Because now the circuit is incomplete here. The circuit is incomplete because we have taken out the connection of this bulb B. Replace this bulb B by a fused bulb. Now, if when you will place here a fused bulb, again you will notice that the bulb A does not glow because this bulb that we have connected here is also fused one, and because of this fused bulb the connection is also not complete and the bulb A does not glow. But in this experiment too, you can see here two bulbs are connected and these bulbs are connected in parallel, and these are the switches S1 and S2 that are connected to a cell. Okay, now close both the switches. Okay, now when you will close both the switches S1 and S2, you will find that both the bulbs glow. Now close only the switch S1 and leave the switch S2 open. You will find that the bulb A glows but the bulb B does not glow. Means when you will switch off this S1 and you open this switch S2, what will happen? This bulb A will glow because the switch is closed, and here as you can see the switch is not closed, that is open. The connection is not complete here, therefore the bulb B does not glow. Now in this figure you can see S1 is open and S2 is closed. Now you will notice that this bulb B will glow and this bulb will not glow. Okay, this bulb does not glow and bulb B glows. Now replace the bulb B by a fused bulb. Now replace this bulb B by a fused bulb and close both the switches S1 and S2. You will notice that as bulb A still glows but the bulb B being fused does not glow. Here you can see bulb A will glow because this S1 switch is closed. Here S2 switch is closed but this bulb B will not glow because of this fused bulb, because this is a fused bulb and here the connection is not complete. Now from the above experiment you conclude that in series connection, if one bulb is removed or it is fused, the other bulb does not glow on closing the switch, but in parallel connection a bulb glows irrespective of whether the other bulb glows or not. As you have seen here, when these bulbs are connected in series, when if one bulb is fused or the connection is broken here, the other bulb will not does not glow. But in case of a parallel connection, if one bulb is fused, the other bulb glows. Okay. Thus, it is clear that all the electrical appliances in our home, offices, schools, factories are connected in parallel. Each appliance has an independent path for current and works at the same voltage. Okay. Now, hazards of electricity. Apart from uses of electricity, there are a number of hazards too. First one is when you use a number of electrical gadgets connected in a circuit at the same time, heavy current flows through the circuit, and because of this overloaded circuit, okay, there will be overheating in the electric wires, which may cause short circuiting or even electric fire. Second, sometimes due to poor insulation of wires, the live wire touches the neutral wire. This causes short circuiting and flow of current becomes excess, and this excess flow of current damages the electrical appliances such as TV, refrigerator, tube lights, etc. Even the wires catch fire, and there can be a mishap in form of electric fire. Third, if a person comes in contact with a live wire, he gets electric shock. If it is a huge shock, it can cause an ultimately untimely death. Okay. Now, this is your lesson number. This was your lesson number 8, A part. You have to read this lesson. Okay. And also you have to learn all the question answers that I have already given. So this is all for today. Thank you.